Let's try question 21 and then 23. We're told that men's heights are approximately normal with a mean of 68 and a standard deviation of 2.5 inches. The percentage of this group of men who are taller than 6 feet is, well, we have to change this question to correspond to the information we have. So the information we have is in inches, so we need to translate this into inches. So 6 feet times 12 is 72 inches. That's the value that we want to calculate the probability of. The probability of men whose heights are greater than 72, the proportion of men whose heights are greater than 72 inches is, that's what we want to figure out. This is a type 1 problem, which we could flip once we first, I think we can turn the sign around, right? But we first have to standardize this. It's a type 1 problem. Standardizing this to begin with, making it a Z greater than 72 minus 68 divided by 2.5 is what we want. And so Z greater than 1.6. Alright, so we want to find 1.6. We want to go this way. But the table gives us only the left side, and we discussed doing this two ways. Either I could change the sign in the direction of the question and get my answer directly. If I look up changing the sign from greater than to less than, and changing the direction from greater than to less than, and the sign from positive to negative, I can get the same answer as if I did it another way. Looking on the margins of the table for negative 1.6 on the negative table gives me 5.5%. The answer is C. Okay, so this is because if I drew it, if I went like this, 1.6, this area should be the same as this area. Okay. Alternatively, we could have used this original drawing and found 1.6 on the positive table. 1.6 on the positive table gives you 0.9332. Sorry, 0.9452. And then 1 minus that would give us the answer that we're looking for. It would give us 0.0548. So we would have the same answer. And that's question 21. The next one has to do with solving the same sort of problem, except maybe the wording might be a bit confusing. Once I show you, you should be able to do problems like this again. It is a type 1 problem because I'm asked for the proportion. Okay, let's set this up. Given the information that the diameter of a casting, or the diameter, is normal with a mean of 6 and a standard deviation of 1/4, 0.25 centimeters, the proportion that these castings are within 1/2 centimeter of the specification of 6 centimeters is, so what they're asking you to do is go like this between 5.5 and 6.5. So within means a half either way. So you're going minus a half and plus a half. All right, which is really what's really important here. How many standard deviations away does that put us around x? Well, since standard deviations are 0.25, what is 0.5? 0.5 would be two standard deviations, wouldn't it? So the answer here should be 95%. It should be C. That should be the answer. But if you want to carry this out mathematically, you can do it like we've done before, standardizing, because this is a X type 1 problem, standardizing and then using the z-scores on the table to find our answer. So standardizing this gives 5.5 minus 6 divided by the standard deviation 0.25 and 6.5 minus 6 divided by the standard deviation 0.25. And now you're going to see when you punch that in, all it's going to end up being is minus 2 and 2, as I explained before. This would be our answer. So within 2 standard deviations, you could draw, remember, it's not the best drawing, but -2 and 2, and I want this area. Looking those up and doing bigger minus smaller, less than 2, the whole area to the left is 0.9772. The left of -2 is an area of 0.0228. Taking the bigger one minus the smaller gives us, big minus small gives us 0.9544, which, as I explained, predicted, would be our answer C.